Welcome to Manifested Publishers. My name is Mr. Mariga. I want us today to talk about marginal analysis for perishable goods. Marginal analysis for perishable what? Goods. Now, so far under inventory, we've talked about certainty models. Uncertainty models when you don't have what? Stock out cost, and also when you have what? Stock out cost. So today I want us to talk about inventory, inventory management, but for who? Perishable what? Goods, or inventory decisions for perishable goods. Now, what are perishable goods? Perishable goods, we define them as goods that lose value over time. So perishable goods are goods that lose value over what? Time. Goods that lose value over time. Value over time. Okay, so there is a decline in the value over a given time. Good example is something like what? Newspapers. Something like fruits, food products, food and beverage, food and what? Beverage. etc. Okay, some goods here that lose value over time are like stated above, but there are so many examples. Now, as a vendor who stocks perishable goods, perishable goods will only be realized when the supply exceeds what? Demand. When supply exceeds demand, then you will have perishable what? Goods class. Perishable goods. Okay, your supply is greater than what? Your demand. That way. You're going to suffer from perishable goods. So as a vendor of perishable goods, the most optimal is where your demand exceeds your who? Supply. So as a vendor, you want your supply to be less than your what? Demand. To be less than demand. Why? Because when your supply is less than demand, every unit you have supplied or every item you have supplied will be sold. Therefore, you're not going to suffer any goods remaining as unsold. Okay? Right. And as a businessman, what you want to do is to maximize your long-term what? Profitability. Okay? You want to maximize your long-term what? Profitability, and your long-term profitability will be maximized where your marginal profit is higher than your marginal costs. Profitability of goods, of perishable goods here should be such that marginal profit, is greater than marginal what? Loss. Is greater than marginal what? Loss. Okay, that is what you want. Okay, now, and we can do a question. The question I want us to talk about is May 2016. May 2016 is a question I want us to talk about. Have certain data requirements as we go to that May 2016. Number one, you must have your marginal profit. Number two, marginal loss. Then you must have probability of supply being greater than demand. Probability of should be demand being greater than supply. Of supply being lower than what? Demand. So in this case, demand is greater than what? Supply. Demand is greater than supply. And this probability of demand exceeding supply, say, is given by marginal loss plus marginal profits Okay. Then number four is your probability distribution. And your probability distribution is normally two. Either it will be discrete probability distribution, or number two, it will be normal or continuous. Normal or continuous probability distribution. Okay, so let's now go to May 2016. I know you've opened that question. May 2016. Question 3B. Question 3B. This thing, James Macaulay prides himself as the largest sausage supplier in the city. Small freshly baked sausages are the specialty of his shop. He has sought help in determining the number of sausages he should make each year so as to maximize his long-term profitability. From an analysis of past demand, he estimates demand for the sausages as follows: 1800 packets, probability of demand is 0.5, 2000 packets, 0.1, 2200, 0.2, 2400, 0.3, 2600, 0.2, 2800, 0.1, and finally 3000 with the probability of 0.5. The selling price per packet of sausages is 90. The cost per packet, which includes handling and transportation cost, is 65. Sausages that are not sold at the end of the day are sold as day-old merchandise the following day at 30 shillings per packet. So using continuous analysis of probability distribution of demand, advice on the optimal production quantity in packets for the what? Sausages. Now, what we want to determine here is the optimal quantity to do what? To supply, so that you maximize what? Long-term profitability. So that you maximize long-term what? Profitability. And for us to do that, we know long-term profitability is when your marginal profit is greater than your marginal what? Loss. Okay, so we must determine our marginal loss, and we must also determine our marginal profit. So let's do that. Marginal profit. We're going to say your profit is simply your selling price minus your costs, and your selling price is 90, your cost or 65. So that is how much? 25. Now, if that item is not sold in the first day, it is sold the following day at how much? 30. So if you made it at 65 shillings inclusive of transportation, but sold it the following day at 30, you're not going to make a profit. Instead, you're going to make a loss of 65 minus that, which means that is how much? 35. 35. Okay, so we have determined our marginal profit. We've also determined our marginal loss. Then we want to determine the probability that demand is less than what? Supply. Or is not less than, but is greater than supply. Is greater than supply. Is greater than what? Supply. Yeah, that is what we want. That is the most ideal situation. Remember, when your demand is greater than supply, you're going to sell everything. But when your supply is greater than what? Your demand, there are some certain units at the end of the period that will not be done what? Sold. And those ones are the ones that are bringing issues of perishable goods. Okay? Okay, so what will we say? Probability, we're going to say, of demand being greater than what? Supply. What will you say? Marginal loss divided by marginal loss plus marginal who? Profit. Your marginal loss is 35. Then 35 plus 25. 0.5833. So the probability of demand exceeding supply, or supply being lower than your demand, is how much? 0.583. Then they're telling us to assume that our distribution is continuous. So one, assume continuous or normal distribution. Assume continuous or normal distribution. We know with normal distribution, Z is equals to your reorder level X minus the mean divided by standard who? Deviation. Divided by standard deviation. Okay, so we want our reorder level, we want the mean, and we want our standard deviation, and we also need Z. But for us to do that, we will have to draw our probability to capture everything in probability distribution. You have your demand and probability of demand 18, 2000, 22, 24, 26, 28, and 3000. 0.05, 0.10, 0.20, 0.30, 0.20, 0.10, and finally 0.05. Okay, that is probability of demand. Okay, then we want probability that demand will be greater than or equal to supply. Probability that demand will be greater than or equal to supply. The probability that demand will be greater than what? Supply. Will be greater than supply or equal to supply. Okay, if your demand is 1800, this will be 1. Why? Because probability of demand being greater, being equal to 1800 is what? 0.05. Probability of demand being more than 1800 is, when you have a demand of 2000, is 0.1. When you have a demand of 2200 is 0.2. When you have a demand of 2400 is 0.3. A demand of 26 is 0.2. A demand of 2080 is 0.1. And a demand of 3000 is 0.05. So therefore, the probability that demand is greater than is a supply of 1800 is what? 0.05. Or rather is 1, not 0.05, is 1. Okay. Now, the probability of your demand being greater than what? Supply of 2000. What will you do? You're simply going to take 1 minus 0.05. 1 minus 0.05. Which will be 0.95. And how is that? You want where demand is more than, supply is more than what? 2000. Where your demand is more than 2000 is from 2000 all the way to what? 3000, which is the same as saying 1 minus 0.05. Demand is more than supply. This will be 0.85, 0.65, 0.35, 0.15, 0.05. I hope that is clear. Remember, we want our demand to be more than supply. Our demand to be more than what? Supply. Okay. Now that we have that, we are assuming what? That ours is normal what? Distribution. It is normal distribution or continuous. We know that we need our mean. We also need our standard deviation. So this is what we will do. This is what we will do. Come here and determine our mean. And how do we get our mean, class? How do we get our mean? We say when you have probability and observations, you simply will multiply the probability times what? Your observations. Your probability times your what? Observations. I will come back to this when we talking about discrete. But however, let me come back here. Okay, we will talk about that. Let's first get our mean. 1800 times 0.05 plus 2000 times 0.1 plus 2200 times point what? 0.2 plus 2400 times 0.3 plus 2600 times point what? 2 plus 2800 times 0.1 plus 3000 times 0.05. So your mean is 2400. Your mean is 2400. Let's get the standard deviation. Let me draw it here. I've said I'll come back to this later on. Let me do away with it. I will repeat it when you get to discrete. Let me do away with that. The moment we don't need it. Just a moment, just a moment. Let me see, let me recalculate this mean again. So 0.05, 18, 24. To 89.82. Now, your probability that your demand is, and this should be your supply, and this should be your demand. Your probability that your demand is greater than your supply is 0.5883. The mean of 2400. So therefore, you want this side. Why? This mean demand is 2400, but you want it to be, your supply to be less than what? 2400. So you want to get that, your reorder level there. This is what you want. So come here. This is 0.5. So this should be 0.58 3 minus 0.508 833. Yeah. Is what you want. Anything less than your demand, but you know your mean demand currently is how much? Is 24. So you want something less than 2400. So it is to the left of the mean. It's to the left of the what? Of the mean. Okay. So let's go to our Z tables. Our Z, you want how much? With the probability of 0.833. This is probability, so you're going to read outside the Z tables. You're going to read outside it. From your tables, from your normal distribution table, you go inside the table because you have a probability of what? 0.0833. So the Z value, given your probability, so use value of Z (0.08). You can say 0.21, and this should be negative. Why? No, you can just have it there 0.1. I will, when we're inputting it, I will have it as a negative. Why? Because it is to the left of the mean. So when you are inputting it, we will have it as a negative. We'll have it as a negative, but let me write it there as a positive. Now we have everything here. Z is there. Reorder level is what we want, our mean and that. So now we've said, because it is to the left of the mean, your Z value should be negative, is equals to your reorder level or your supply. This is your supply, in fact. This is your supply. You can even change this and refer to this as your supply. Your supply. You want to determine the quantity to supply. So let's call it supply instead of reorder level, so that we're very, very clear. Supply. There. Let's also call this supply. You want to determine the quantity to supply. Your mean is 2400. Your standard deviation was 289.82. 289.82. All right, supply instead of reorder level. So let's refer to this as supply here also. So we need to determine our supply. Times 289.82. So your supply should be 239. 2339.1378. 2339.1378. 1378. So for the company to be able to maximize long-term profitability, or they have a perishable good, they should supply 2339.1378 units. This is what they should supply. Okay. Now, let's assume this is not continuous, it is discrete now. Assume discrete distribution. Assume discrete distribution. We have our demand, our probability of demand, 1800, $2,000, 22, 24, 26, 28, 3,000, okay. Then the most ideal situation is where your demand is greater than your what? supply, where your demand is greater than your what, or equal to supply. That is the best situation for you, so that will be 1. But it is 18 and all that is greater than that. And this will be 1 minus that be 0.95. I think I had calculated that a few. It's only that I did away with that. 0.85, 0.65. For the demand to be more than 2400 is 0.65. It is 0.35, 0.15. And finally, where demand is more than 2800, (0.05). Right, that is what you want. That probability is giving us what? The probability of demand being greater or equal to supply. Demand of more than 1800 or equal to 1800 is 0.5 plus 0.1 plus 0.2 plus 0.3, 0.2 plus 0.1 plus 0.05, which is what? 1. Okay. Demand of it being 2000 and more than 2000 is 0.1, 0.2, 0.3, 0.2, 0.2 and 0.5, which is 0.95. Demand of more than 22 or equal to 2200 is 0.2 plus that plus that plus that plus that is 0.85. Demand of more than 2400 or equal to 2400 is 0.3 plus 0.2 plus 0.1 plus 0.5 is 0.65. Demand of more than 2600 or equal to 2600, 0.2, 0.1, 0.5 is 0.35. Demand of more than 28 or equal to 2800 is 0.1 plus 0.05 that. Demand of more than 3000 or equal to 3000 is simply 0.05. Your probability that demand is greater than supply was 0.58. So you want here 0.5833. That is what you want. Okay, so therefore you supply, you extrapolate, you'll say 2400 plus 0.65 minus 0.5833. You want something between 0.65 to 0.58. Divide that by 0.65 minus 0.35. Okay, then this difference, which is what? 200, which is 26 minus 24 minus 2400. All right, why? Because you know between 0.65 and 0.35 your demand is 200 here, but remember you don't want the whole 200, you only want a proportion between 0.65 and 0.58. So let's work that one out. So this will give you 2400. So for that company to maximize long-term profitability, they will need to supply how many? 2444.467, which we can simply round off as 2444 packets of who? Sausages. That is what the vendor should supply, so that they maximize on what? Long-term profitability. And that is how you deal with what? Perishable goods. That is how you deal with perishable what? Goods. So remember, you must identify your marginal profit, your marginal loss, the probability that supply is less than demand or demand is greater than supply. which is determined that, then your probability distribution will either be discrete or what? Continuous. Okay. If it is what? Continuous, this is what you use. Z or is equal to supply x minus the mean divided by standard deviation, then you simply substitute. But now the tricky bit, and what I want you to remember is that you want where your supply is less than your demand. So if your mean demand is 24, you want anything less than 2400, so it should be to the left of your mean, to the left of your mean, and anything to the left of your mean means you should be a negative here. It should be a negative. Z should be a negative. So you go to your table and the value you get, you have it as a negative. Have it as a negative. Okay, because you want something less than 2400, and from our question it is true. We have less than 24, which is 2339.1378. Then if it is what? Discrete, assume discrete distribution here, 0.5833, then you now extrapolate. All right, I hope that has been understood. I hope that has been properly understood. Okay, now we want to say that is that. So unless there is a question, that is how you deal with perishable what? Goods. That is how you deal with perishable goods. So unless there is a question, we want to introduce something else, but not in this particular lesson. We can only introduce it in the next lesson. And in the next lesson, we want to talk about simulation of inventory. We want to talk about what? Simulation. So we will call it a day. And in the next lesson, we talk about what? Simulation of inventory. So goodbye and see you in the next lesson.